We're going to be learning something called complete the square. The goal is to take this quadratic, which is currently in standard form, and convert it into graphing form, which will show us the vertex. Right now, the only information provided from this form of the equation is that the y-intercept is at 10. But it'd be nice to know where the vertex is. So what we do is we almost start like we're factoring. We're going to start with our rectangle. And in the lower corner, we're going to put the x squared. But we're not going to put the 10 diagonal from that. Instead, we're going to force this to be what's called a perfect square. So these 8x tiles have to get split in half, so that exactly half go into each other diagonal. So we're going to put 4x's here and 4x's here. And if we re-added those together, we would get the 8x from the original 8x's. So now we act like we're factoring. In order to create these tiles, to make an x squared, we'd have an x multiplied by an x. And to have the 4, we'd have 4 and 4. And so filling in that last box, we would be doing a 4 times 4, which would make 16. The problem is this does not match the original equation. The x squared matches, the 4x and 4x matches with 8x, but 16 does not match the original equation. So we have to go backwards from where we are now back to that original. So how do I get from 16 tiles back to how many I should have? I'm supposed to only have 10. So in my mind, I think that I have to take away an extra 6 tiles in order to match my original equation. So the way that we write this is we write that we have a square. It's x plus 4 by x plus 4, or x plus 4 squared. And then we have to take away 6 tiles to get back to the original. This is called graphing form or vertex form of the equation. When we look at this, it tells us the coordinate of the vertex is at -4, -6. We'll do a couple more examples. So we need to, again, complete the square, draw a tile to help her figure out how to make this into a square. So we have our equation here. So when we start making the square, we're going to put in the x squared. And then instead of putting the 9 in the diagonal, we're instead going to use this 4x in the middle. We're going to split it in half. 4 divided by 2 is 2, so that 2 x's go into each corner, so that when we add those together, we get 4x again. Now we pretend like we're factoring. X times x makes x squared. We would have plus 2. And to get this last corner, 2 times 2 would be 4. But that doesn't match our original. So our square is x plus 2 by x plus 2, or x plus 2 squared. But we need to get back to the original equation. Our square currently has 4, and we're supposed to have 9 tiles. So we're short. We need to add 5 more tiles. So we'll do a plus 5. This is our graphing form or vertex form of the equation. And if we wanted to write the coordinate of the vertex is at -2, +5. If we wanted to know the y-intercept is given in the original equation here at 9, so I'll just make a note of that. The y-intercept is 0, 9. The only thing we don't have in either format is the x-intercepts. We can find the x-intercepts if we take this graphing form or vertex form equation and write it where we're trying to solve for when the y would be 0. So we're going to be solving 0 equals x plus 2 squared plus 5. So first thing we need to do is get the x by itself. We're going to minus 5 on both sides. X plus 2 squared equals -5. Then we can take the square root of both sides to undo the squared. And we get x plus 2 equals. But the square root of -5? That's not possible. Nothing squared is going to create -5. So what does that mean for us? It means that this has no x-intercepts. On a graph, this parabola would look something like this. It has a y-intercept up at 9, a vertex at -2, 5, and it goes like this. It never comes down to the x-axis. I'll do one more quick example of complete the square. This time, the equation is x squared plus 5x plus 2. So if we start making the rectangle, we're going to put x squared in the corner. We have this 5x that we have to split in half. And we can do that. 5 divided by 2 is 2.5. So we're just going to have a decimal this time, 2.5x in each corner. In factoring, you never use decimals, but in complete the square, it's possible. So you would have an x by x and a 2.5. And if we multiply 2.5 times 2.5, we get 6.25. And so we compare our 6.25, that's what we have, but we're supposed to only have 2. So we're going to have to take away a few. And to write our final answer, we'll have x plus 2.5 squared, and we have to take away 4.25. And this would be our graphing form, and it helps us to find our vertex.